Mars Myth to Magic. So I'm sure you all know Neal, right? Do you want me to do your bio, Neal? Okay, Neal Farber. Neal Farber is Professor Emeritus of Clinical Medicine of University of California, San Diego, and a docent at the San Diego Air and Space Museum since November 2018. He obtained his undergraduate degree cum laude in biology at Franklin and Marshall College, Lancaster, Pennsylvania in 1972, where he was Alpha Beta Kappa. He went on to get his medical degree from the University of Pennsylvania in Philadelphia in 1976, where he was elected for Alpha Omega Alpha, the National Medical School Honor Society. He went to complete a residency in internal medicine at Temple University Hospital in Philadelphia. For the past 12 years, he was professor of clinical medicine at the University of California, San Diego, retiring at the end of April 2018. His interests are in education and teaching, especially in regards to communication skills. He's always had an interest in space flight and World War II aircraft, and now as a docent on Mondays and Fridays. He serves as the museum's docent training coordinator since 2021. He's a NASA ambassador recently and gives multiple talks on space-related topics. Welcome, Neal. Thank you.
So you forgot to mention he's basically a nice guy.
That's it.
Actually, I should correct that. I said, oh yeah, that's right. Okay, go ahead, Neal.
So thank you. So when you hear the word Mars, what do you think of?
Candy bars.
Candy bars, okay. I asked that for a particular reason, because Mars has a really interesting story. Over the years, over the millennia, it has changed. One thing happened, and then that got debunked, and then another thing happened. So, for example, ancient people saw Mars as a god. The only thing they could see was this red dot moving across the sky, and interpreted it basically as a god. We'll talk about that in a minute. Fast forward a couple of millennia, and you have the invention of the telescope. And then suddenly people actually saw the face of Mars, and they saw the markings on Mars, but they misinterpreted what those markings were, what they meant. Fast forward to the space era, for the first probes that flew by Mars, and they were 2,000 to 6,000 miles away, and so got sort of photographs of it, and suddenly thought, all that's not true. Mars is just a dead planet, just like the moon. And then we had better probes that orbited Mars, that actually landed on Mars, and that's when the magic came. And I'll talk about that. So the ancient people saw Mars as a god, basically. And part of that was, why is this not working?
Spacebar.
Spacebar? Nothing's working.
Reach down.
There we go. Went too far. So basically they saw this planet, what they called, the Greek called the planets. They named them because of the fact that it in Greek it is wanderer. And they saw this planet wandering across the sky. They deemed this a god. The Greeks called it Ares, the Romans called it Mars, because they thought it had a fiery personality. It was blood red in color, and it had changes in brightness because of the orbit of Mars. And so they thought it was basically like a pulsating heart. And they thought that according to the temperament of it, whether it was bright or not bright, it would predict omens. And so this is what they saw as being one of the Martians, if you will. The orbit of Mars was first worked out by Johannes Kepler in 1609, and realized that the orbit was actually oval, that it's closest to the sun at about 200 million miles, but farthest away at about 250 million miles. And this causes an eccentricity in its seasons. It has the axis that's close to Earth. Earth's axis is about 23 degrees. Mars is about 25 degrees, so they're fairly close. But because of that eccentric orbit, the southern hemisphere gets much longer, colder winters, whereas the northern hemisphere, although the summers are shorter, they're much warmer. And you can see in the orbit, this is Earth's orbit, and it's fairly circular. But Mars has, at its closest, is here, but further away when it's out here. So we get to the point where they're the first telescopes. And Galileo didn't see Mars, I guess he just didn't focus on it. But Christian Huygens in 1659 discovered the markings on Mars. And Cassini spotted bright areas at the poles, which he believed were ice. And then in the 1830s, Bohr and von Madler mapped all the light and dark areas on Mars.
There you go, try it again.
Okay,
Okay,
that go forward.
okay, thank you. So you could see the light and dark areas. The southern hemisphere have these dark areas on Mars, whereas the northern hemisphere has all these brighter reddish areas. Well, then we get different myths in the 1800s. Early on in the 1860s, John Phillips postulated about the markings. He thought that the northern hemisphere, which was reddish, was land, and the grayish southern hemisphere was water. So these seas, basically. Schiaparelli saw new markings on Mars, these linear areas that he thought were, he named canali, or canals. Well, then Percival Lovell in the 1800s put this all together and said, well, the blue-green areas are seas, clearly, and the canals were made to bring water to the northern area, which is drier, and so there are intelligent beings on Mars. And that was sort of the myth then. And you could see that the drawings at the time by Lowell indicated that there were all these canals on Mars. Well, there weren't nearly that many. There was only a few. And this is also what he thought. And what happened is, basically there was a debunking of the idea that these were canals and that they were intelligent beings. Barnard, who was a California astronomer, advised caution that there could be other explanations. And in fact, Wallace calculated that the temperature on Mars would be bitterly cold because of where it sat in its orbit. And further observations in 1909 indicated that the markings weren't actually canals. What they were actually were these cracks in the crust, for as Mars was shrinking early in its formation, it sort of buckled and caused these deep canyons. Fast forward to the early space age. This finally put to rest the idea that there were intelligent beings on Mars. Mariner 4 passed within 6,000 miles of Mars and found that the atmosphere was less than 1% that of Earth's. So probably wouldn't be able to support any significant life. And in fact, the atmosphere that was there was made up of about 95% carbon dioxide. Mariner 6 passed closer to Mars in 1969, about 2,000 miles, and they found there were no Earth-like features, only craters, and that the poles were made up of solid CO2, dry ice. And you can see that it found all these large and smaller craters throughout. The Soviet Union, from Mars 2 and 3 in 1971, were unable to visualize the surface because of the global dust storm. But they did recognize, and it was later found, that all of the dust is very fine, like talcum powder, and it's all magnetized because of iron. They did also determine that the temperatures on Mars were minus 166 degrees Fahrenheit at the poles, and anywhere from minus 135 to plus 10 degrees Fahrenheit on the rest of Mars. So very bitterly cold. And the US Mariner 9 in 1971 had some of the best images of Mars and also imaged the biggest volcano in the solar system. And again, all these craters, you can see that this is a world that just has all these craters on it, just like the moon. And this was the image of Olympus Mons, which is the largest volcano in the universe, or in the solar system, I should say universe.
Spaceport.
Press what?
Spaceport.
Spaceport? Okay, great, thank you. And this is a closer picture of it, and you can see that basically it is something like 800 miles across and about 80,000 feet from bottom to top. So it is the largest volcano in the solar system. So at this point, we think Mars is a dead, forsaken planet, right? Now the magic happens. Viking orbiters and landers were in 1976. So the orbiting findings were an Earth-like style of valley networks. That is, small tributaries merging into rivers or deltas. That's what it looked like. Now, we didn't think there was active water, but it looked that way. And therefore, the hint was there might have been the presence of liquid water in Mars's past. We weren't sure yet, because this is from an orbiter. The Viking lander was the first spacecraft to actually soft land on Mars, and it found highly reactive compounds in the soil.
What's that mean?
That means that there's probably water in the past, because the highly reactive compounds meant that it had merged with water in the past, making it highly reactive in the present time. And these are, I don't know if you could see it well, but you see up here sort of this fan-like appearance, like a delta. That's what they were seeing, and it looked like it had been water at some point in the past, although there was no way they could be sure at this point. Because when they actually did land with Viking 1, basically you see this dry desert-like area and nothing else. A more advanced orbiter, which was Global Surveyor in March of 1999, took high-resolution images and found something interesting. They looked like sedimentary layers, like something geologic was happening in the past. Now, it could have been just multiple wind deposits, because we know that Mars has all these global storms. Or it could have been meteoroid events, impacts that were happening. You know, Mars has lots of meteoroids. It could have been volcanic eruptions. We've seen ancient volcanoes on Mars, so these could be multiple eruptions of volcanoes, although where the actual lander happened wasn't where there were any volcanoes. And the last possibility is that there was water in the past, that these were deltas, actual deltas that were visualized, or the remnants of deltas. And you can see that clearly this looks like sedimentary deposits, these kinds of things. And this was from the orbiter. You can't make much of that in terms of why they're there, but it's clear that there are some kind of layering effect. You know, closer up view shows it even more clearly. The question was, what does this mean? But there were problems with the landers. First of all, most importantly, it was stuck in one place. So it didn't get to go exactly where they would want to go. Also, there were a limited number and complexity of the instruments, so they couldn't adequately examine what was around them. And they had a limited ability to transmit images back to Earth. So NASA decided, we need some rovers. We need something to be able to move around the planet. And not far, obviously, but at least in some places. So these were the early rovers that were developed. Sojourner, in July of 1997, was basically a technological examination of could we have a rover on Mars, could it function. The thing was about this size, so it wasn't anything to speak of. But it did give us some 3D representations of the Mars surface around where it was, and it did look at the chemistry of some loose dust and soil around where it was going. It did not go far, it did not last long, but it showed us that we could have rovers on Mars. Going further, Spirit and Opportunity were twins. Spirit was in March of 2004, Opportunity in April 2004, both landed successfully. Spirit was in an area that was believed to be a hot spring in the past. At least that was what the thought was. Opportunity found something interesting. Where it landed, it found clearly sedimentary rocks. And it found a mineral called jarosite. And jarosite is found only in watery environments on Earth. So it seemed clear that probably there was water in the past. One of the problems, though, was this was its landing mechanism. It was a big kind of puffball that literally bounced along on Mars, and when it stopped, it deflated, and that's where you were. There wasn't any pinpoint landing. It was a general area. This is a picture of Sojourner, the earliest rover, and you can see that, I mean, this looks like a huge boulder. It's a rock about this size. That gives you an idea of how big it was. And it has solar panels on the top. these solar panels would get covered with dust and then the rover wouldn't function any longer. But it did find out some things.
Who took the picture? Who took the picture?
The lander. They had a camera on that big puffball.
Oh, okay.
Inside the puffball was a lander that then discharged Sojourner onto the planet. The lander itself had a camera on it. There weren't aliens taking it. But this is Sojourner sort of grinding into the rock to try and find out what was there. This was Spirit on Mars, and that was in an area believed to be an ancient hot spring. You see these white areas were believed to be salt deposits. And these are the wheel tracks from Opportunity. And you can see, this is seen by Opportunity, you could see sedimentary rock. This is clearly sedimentary. Those pictures from the orbiter are documented by Opportunity to be, at least in one area, these kinds of sedimentary rock. And again, it could be anything, but the fact that jarosite was there makes it believed, at least, that these are water-based. We're not sure yet. So the question was there really water on Mars? And was there any more evidence to support this? Because if present, it might indicate a very different ancient Mars than we conceive of. It might be one that's not only wetter, with perhaps liquid flowing water on the surface, but also warmer. And that leads to the possibility of life. You need three things for life. You need to have persistent liquid water, or liquid something. We're only used to water as a solvent. You have to have minerals that lead you to be able to form life. Carbon, oxygen, nitrogen, sulfur, all the different atoms that are necessary to come together to form life. And you need to have some energy for metabolism. Well, perhaps...
What does metabolism mean? What does metabolism mean?
Metabolism is the organism, whatever it is, ability to take compounds like sugars, combine them in such a way that you develop energy for the organism to function. That's how we function.
Function and reproduce, isn't it?
To function, reproduce, etc. That's how we function. That's how anything that is alive functions. It takes in compounds, metabolizes them, meaning it combines them in certain ways that allows compounds that are inherently energetic to provide the energy for the organism to move, if it moves, to grow, to reproduce, etc.
Oxygen? Any water on the planet would be frozen, wouldn't it?
Ah, now it would be frozen. The question is, was Mars warmer and wetter? I'll give you a hint. In another lecture that I'll be giving in October, I'll talk about this. But early on in our sun's history, it was much either cooler or warmer, depending. And Mars might not have been in the orbit it is in now. It might have been closer in. There's something called a habitable zone around a star, where if you're within that habitable zone, like luckily Earth is, you have the potential for forming life. Well, Mars might have been within that habitable zone earlier on.
Could I do a follow-up on that?
Yeah.
You said there's carbon dioxide. Where does that come from?
The carbon dioxide can come, And we all think of that we take in oxygen and exhale carbon dioxide, which is true. But carbon dioxide also is a naturally occurring element. If you have carbon and you have oxygen, they will combine and form carbon dioxide.
And if Mars had had an atmosphere much earlier on, that would have increased the temperature as well. It could have had a greenhouse
That's right.
effect as well. So
That's right. If you had more atmosphere, it would have increased the temperature as well.
But the three items you talked about for life, the oxygen, where does it fall in?
Oxygen is not necessarily, well, oxygen is necessary to form some of the compounds, but not in a way you're thinking of in terms of breathing in. For example, plants do not require oxygen. They make their own oxygen, for example. And the other question is, was this water and life, was it just ancient or was it ongoing? We didn't know. And therefore, NASA decided to launch a number of orbiters and landers that were much more sophisticated. Odyssey was a polar orbiter in October 2001, so it orbited the poles of Mars. And through instruments found significant ground ice under the Martian surface. So there's a surface of Mars with all this dust and stuff, but underneath that dust on the covering, there's ground ice below. We weren't sure whether this ice underneath was water or carbon dioxide yet. But this is the Mars Odyssey that's orbiting, and you can see that this is an artist's conception, but that this all these areas have ground ice underneath the surface. So the Mars Reconnaissance Orbiter achieved Mars orbit in 2006. Found a couple of interesting things. They found that there were gullies newly forming on Mars still. Now they believed it was probably dry flows of dust or soil, but Mars was still geologically active at least. Also, there was dark material flowing down rocky slopes, coming out of the ground, flowing down rocky slopes. And the spectrometer on board found that that was actually water. So Mars still has water coming out of the ground, flowing down slopes. That means there still is liquid water on Mars. It's down low, underneath, but there is some, yeah.
Okay, Neal, if you got flowing water, that means it's within 32 degrees to 212 degrees Fahrenheit since it's liquid.
Right.
it could be supersaturated with minerals,
Well,
which lowers the
well,
melting point.
again-
Just a second. You can't flow if you're solid, so how's the temperature in that local area enough to allow water to flow?
It's not. It happens very quickly and the water actually either freezes and sublimes.
Okay.
But what happens, we believe anyway, is that deep down, because of radioactive minerals and still geologic activity, it's superheated water that's then erupted.
Okay.
But again, if you add salt to water, the melting point drops a lot. These things are deep underground. They're full of minerals, supersaturated. So,
Yeah,
the melting point could be minus
Well,
100, minus.
that's deep underground. It's like an 800-pound steam plant.
No, they carry
you know?
the minerals up, so they're dissolved in it.
The point I was making is once it's exposed to the Martian surface,
Yes,
it couldn't be liquid unless it was local
Correct.
warming.
No,
Correct.
But again, that liquid water,
Well-
just like if you had salt, if you dissolve salt in liquid water on the surface here, the melting point goes way down.
during the
Yeah.
summer,
That
during the
has a lot of
summers on
dissolved
Mars,
minerals in it.
Huh?
So could be a lot lower.
during the summers in the northern hemisphere of Mars, it does get up to positive 70 degrees.
Okay.
So at times you might see it.
Mhm.
Does that mean there is life actually there? No, not necessarily. We'll get to that in a minute. But we now know that at least Mars is an active planet. It's not dead. Now that doesn't mean it's alive with life, but it's geologically an active planet. That gives us some hope. And you can see, these are the gullies they were talking about. And these were newly formed. And again, these gullies, believed to be possibly liquid water. Now, a couple of things happened since then. The Phoenix project landed in the Martian Arctic in May of 2008. There were trenches that were dug exposing white patches. And a spectrometer confirmed that these were water ice, not carbon dioxide ice. Okay, so there is, again, all that ice that's under the surface is water ice. And this is an artist's concept of that Phoenix project lander. These are the white patches that were dug, and you can see right under the surface there is this white stuff that is ice. Now, we don't know how much ice there is. This is right under the surface. We don't know how deep it goes, and we don't know how much it is, but probably a lot.
There was some previous pictures that showed white underneath, and that they thought that was that the Odyssey, or no, the Spirit, where it was landed in the thermal hot spring area?
Right.
That was salt.
Yeah.
But
That
now
could have
they're
been.
saying
That could have been ice.
That could have been ice. Okay.
Yeah. Yeah. The thinking at the time was that it was salt. It could have been
Yeah.
ice.
Okay.
And if that's the case, then there's ice all over Mars.
Mhm.
But Neal, the question, this ice is ice only, water ice, or mix of CO2, dry ice and water
This
ice?
was all water ice.
The whole
The
water-
poles are dry ice, but the subsurface ice is all water ice.
Was that near the equator, or where was that? Was it near the equator doing a warmer spot? Or?
Where the Phoenix lander was, I'm not sure. It was in the northern hemisphere. I don't know exactly how close to the equator. So basically, NASA decided we needed bigger rovers. We needed more information about the water, proof that Mars at least once had a habitable environment, even if not now. There were problems with the smaller rovers. First of all, they didn't have enough instruments. They were all powered by solar panels, which after a year or so got covered with dust and no longer functioned adequately. And didn't have a specific location since they had those landing bags. We wanted to have it in a specific location to look at different areas. So larger rovers were designed to build, and they designed a new way of landing. So Curiosity and Perseverance were the two rovers that still are on Mars functioning. Instead of having Spirit and Opportunity, which are about this big, literally, they're about as big as an SUV. You saw the model of Curiosity in the museum. That was their actual size, about the size of a small SUV. They had a large number of instruments and cameras. Curiosity has 17 cameras on board and 4 spectrometers. And they're powered by a thermoelectric power generator, which is a whole different way of powering these things. You can see, basically, this is Curiosity when it landed on Mars. And that was at Sol 84, meaning it had been on Mars for 84 Martian days. Mars's day is a little bit longer than Earth's day. And now, after a time on Mars, it looks like this. And that's at 3,303 days. And this was a while ago. It's still going. It was only supposed to go 2 years. It's now been more than 10 years and still functioning. The reason being that this is the thermoelectric power generator. The key is, in here sits a chunk of plutonium. And it's not a reactor, like a nuclear reactor, but that chunk of plutonium naturally decays, gives off heat. And as it gives off heat, it can be turned into electricity. The landing was complex. It had a heat shield, parachutes, rockets, and then finally a crane that lowered the lander to a specific location. And this is a drawing of it. You can see it has this heat shield that comes in. The heat shield is separated. It has this very huge parachute to then slow it further. Then the basic components separate from the back shell, and this has these have rockets that slow it down to 0 acceleration, and a crane then lowers the rover to the Mars surface. So very complicated.
How fast is it going when it comes out of orbit?
Out of orbit, it's at 25,000 miles an hour,
Whoa.
and then goes to 0.
Speaking of cross-culture, they had a heck of a time figuring out how to stow those parachutes in the landers, so they consulted origami experts who told them how to fold the parachutes.
Yeah.
When I first saw the general schematic of what they were planning on doing,
No way.
I gave them 0%.
No.
Yeah,
Twice successfully.
Twice successful.
Twice successful.
Without issues.
Without issues and without any contact with the rover.
Right.
Because remember, Mars is about 8 to 10 minutes away in terms of communication, right? Because it's anywhere from a couple hundred miles, 50 to 150 miles away from Earth. So it's anywhere from 6 to what?
As long as 41 minutes.
8, 9 minutes. So basically, they radio up instructions and pray. And then once they get back the signal, they know they're okay. But these are the rockets firing and the crane lowering it down onto the Martian surface. And then when they have contact, the crane separates and this thing flies away.
Another cross-culture thing is those tires have holes in them. Everyone said, oh, is that to get rid of the rocks? No, it's Morse code that spells out change.
Yeah. So Curiosity landed where it was intended, 100 yards from where it was intended, almost right on top. Designed to last 2 years. It landed in 2012 and is still going. So this was last year, it was 10 years later, now it's 11 years later. It's traveled over more than 17 miles of surface, and it has had many important findings. First of all, the surface around the landing site is made of pebbles, and these are all sedimentary. Okay? Many of the rocks and pebbles are rounded. We now know that's due to liquid water that was on Mars' surface. Further away is still even more extensive sedimentary rock scene. We now know that Mars was a wet world in the past. And the water was low in salinity and neutral pH, which means it's a very suitable environment for developing life.
Neal, how do they know that it was neutral pH?
From its spectrometer. The other thing is they drilled and found, Curiosity drilled and found the building blocks of life: carbon, oxygen, nitrogen, hydrogen, phosphorus, sulfur. Those are the things you mainly need for life, and they were all there. It did find also, interestingly, organic molecules. Now the problem is it couldn't distinguish what organic molecules. Small organic molecules, ethane, propane, methane, are very small molecules, and they can form naturally. If you get up to the point where you're finding amino acids, complex sugars like DNA and RNA, those are not just naturally occurring. That means life. Now, we don't know yet. At this point, we don't know. This was the Curiosity landing site. This was basically an area where there was a river that came down. You can see there's rocks that are conglomerates. These are clearly sedimentary, just like the stuff you see on Earth. Rounded pebbles, that's all erosion from liquid water. Perseverance landed in 2021 in February at Jezero Crater. The location was a river outflow channel and delta, and this is the best place to look for ancient life, because as the river comes down, it deposits all the silt, and that's the best place to look for life. So what Perseverance has been doing for the last 2 years has been drilling core samples in different areas and putting them in titanium tubes. Why? We'll get to in a minute. They also had a helicopter as a trial for the first time on an ancient planet, on a distant planet.
Yay, God.
And it was named Ingenuity. And it looks like no other helicopter you've ever seen because of the thin atmosphere on Mars. It was designed as a technical evaluation, and so it was only designed to have 5 flights and not do any work, i.e. look for things.
Yes, proof of concept.
It has now had more than 50 flights and has been very valuable in finding all kinds of stuff. This is the way NASA works.
Oh, shoot.
This is the landing site of Perseverance. And you can see there's all these rocks being deposited in this area by an ancient river. These are eroded stones at the landing site. Again, liquid water. And that's a model of, this is a photograph actually of Ingenuity in one of its maiden flights. And you see it has 2 rotors that spin at like 10,000 RPM. And it was a lot. A lot of RPM.
Bunch.
Because it has such a thin atmosphere.
Hey,
But
Neal,
it's been very successful.
Neal, could you stop for a second? I'm running out of film here. I need to plug this thing in.
Okay.
I'm sorry to do that, but
That's
So why don't,
sorry. I had 88 minutes when I started, and somehow it went down to 3 minutes, like that fast. Ready, set, go.
Go. Okay. So the question was, why is Perseverance collecting these core samples in titanium tubes? Because in the 2030s, or sooner, depending, there's going to be a return mission that's planned. There's a lander that will land next to Perseverance. It will obtain the samples that have been collected and return them to Earth for study. The plan is to determine if the organic materials that are present, are they just naturally forming, or are they biologic? And that'll give us a handle on whether there really was life on Mars. So what will happen is, you can see the Perseverance trundling up to the lander. This is the lander. And you see the lander has already in its claws one of the tubes. It puts it into a spacecraft in here. That Mars ascent vehicle takes off from here when it's full, docks with the Earth return vehicle, which returns it back to Earth. And there's a shell that goes through the atmosphere, lands in the Utah desert, collected and examined.
How many of those sample containers are there?
I don't know the total number, it's like 24, I think, but it may be more than that, I'm not sure.
The most important part is the entire operation is supervised by one helicopter.
Right.
So noted.
So what have we learned? Well, the surface of Mars now is extremely arid. But in the past, Well, we know that basically there's water in the subsurface soil, maybe lakes, given the fact that there's these outpourings of water sometimes. And these lakes would be subsurface and maybe harbor life, who knows? We know that Mars is not dead. There are active changes at the surface, both these soil and water outbursts. We know that Mars probably had a habitable environment, probably for about 1 billion years, between the time the solar system formed 4.6 billion years ago and maybe around 3 to 3.5 billion years after that, or long ago. So anywhere from 1 billion to 500 million years, there was liquid water on Earth and the possibility of life. And life we know on Earth certainly didn't take that long to form. So it's possible Mars had life in the past.
Neal? Didn't they find out through a lot of these rovers that Mars has a liquid iron core?
Yes.
Okay, so that's where the heat may be coming from, that would give you liquid water below the surface.
That as well as from radioactivity. Radioactivity will also heat.
All right.
There are other interesting ways of heating that we'll get to in my next lecture in October. Okay. That's a teaser. So we know life might have existed on Mars in the past. Now, interestingly, the European Space Agency, Mars Express, found traces of methane gas in the atmosphere. Again, could be naturally occurring, could be because those lakes down below have life going on right now.
So the aliens live underground?
Yeah.
And that's the magic.
It's like New York City.
Yeah. The magic is that Mars is not dead, and Mars was once live, and Mars might be live now, which is incredibly amazing stuff. So this is what's the plans. That was Sojourner, then Spirit and Opportunity, then Curiosity, then Perseverance, then an astronaut.
Yeah, I was up at JPL when they were building the last one. They had a total replica or a second one that they had built.
Cool. So questions?
I want
So
to
the
tell you
planned trip-
something. I get a catalog from a NASA store, and NASA's gotten a sense of humor lately about some of the things that they do, and there's a patch that they're selling. It's obviously a red planet, and there's something that looks like the International Space Station in orbit, and there's a green man standing, and he looks up and he goes, "There goes the neighborhood."
So
I had to buy that patch.
George, I think you were first.
Okay, you said that there's a liquid iron core.
Yeah.
On Earth, that develops a magnetic field. Have they found a
Yeah.
magnetic field on Mars?
There is not a magnetic field, and no one knows exactly why.
So the manned mission schedule is beyond 2030?
The manned mission? No one knows. So we know, in terms of manned missions, we know that Artemis will land on the moon in 2025. Artemis will then set up Artemis 4, 5, 6, 7, who knows what. We'll set up a moon base as well as an orbiting space station. When we will actually take off from Mars, no one has said yet.
Right.
We don't know. But the return mission, which is unmanned,
It's 2030.
is in the 2030s.
Yeah.
So if they have oxygen, or if they have water, they can develop oxygen, right?
That's right.
You know, all those rovers were named by students.
Yes.
Wrote essays.
Yes, that's right.
Very interesting.
The rovers and Ingenuity were all named by students.
Have people also been thinking about what would happen what kind of life they might think about that wasn't based on carbon, hydrogen, oxygen?
Yes. As in Star Trek, the silicon thing. We haven't thought of that because the
He knows what it would
The
look
amount of energy required would be enormous to power, to, you know, something like that would have to eat, you know, 100 times its weight in whatever per day to be able to function. So we haven't thought about that. Same thing with, you know, have they thought about like, for example, on Titan, there's liquid methane rivers and lakes. Could life exist on the surface in liquid methane? Well, it's very unlikely because it's so cold. It just wouldn't support really, that we know of, life that would be able to function in that kind of way. But we'll get to that more in the next talk.
Neal, you got,
Yeah.
So, is there any evidence discovered of igneous deposits due to past volcanic activity?
Yes. We know that some of the rocks had igneous components to it. And we know that basically there were volcanism on Mars. So we just haven't landed in areas where there's lots of igneous material.
Perhaps a lot of it is covered up by dust because of the time.
And
it's
covered up by dust and
going by.
ice.
Yeah.
Yeah. But yes, there probably, if you drill down enough, there would probably be igneous material. Remember, the only time we found igneous material on the moon is when we landed, because we were able to drill down. So it would be the same thing on Mars. We wouldn't know until we get there. But presumably yes, because there were volcanoes.
So one of your pictures, you showed some pebbles that you commented might have been eroded by water, flowing water. Does anybody try to date those pebbles, you know, like with radiocarbon dating, or can you get an age to get a better idea when water might actually have been?
No way of doing that from a rover.
So that's the samples, they're going to do that with the samples?
They
They're going to bring back?
probably will carbon date the samples.
I don't think carbon dating works, you know, that's only good for, I think, 12,000 years.
Right, it's actually not carbon dated, it's
Isotopic
aluminum,
dating like they use on the moon.
it's aluminum and a couple of others that they use. But the technique is the same.
Yeah.
So you can carbon date rocks, is that what you're saying?
No.
No, because it doesn't, carbon doesn't,
Some other method.
yeah. It's a different isotope. Aluminum 27, I believe it is, will last like 800,000 years. So they can use that, for example.
Neal, thank you very much. It's a great talk. Appreciate it.